Welcome to a new episode of the Heat Treat Podcast. Today we have a good friend of mine, a great guest, one of the smartest heat treaters in the United States, Pete Hushek, president of Phoenix Heat Treat. First of all, how's it going, Pete? It's great talking to you about heat treat. Really excited for this episode.
Well, I'm quite excited, Carlos. This is an opportunity that's probably been in the making for over 40 years. So I'm excited to be able to share some of my experiences with your audience.
Thank you so much, Peter. So first of all, if you could just give us an introduction of Phoenix Heat Treat, what do you do in that company? You've been president for that company for more than 35 years.
Right.
You've been very active. You've been president of the Metal Trading Institute. That's when we met.
Right.
And I see that you have also, academic responsibility. So you just could make a very brief introduction of the work, the who you are, first of all, because you're a very well individual in the industry, and the company you work for, please.
Okay. Well, I'm a fourth generation heat treater, and by that, my father, my grandfather, and my great grandfather were all involved in heat treating. Grandfather and great grandfather in Milwaukee, but my father moved the family out to Arizona while my mom was pregnant. So with me, so I was the first one born in Arizona, and from an early age, I heard the challenges of heat treating. My father used to call it the black box. People sent parts in, and sometimes they actually came back black, obviously, if they weren't cleaned and they were processed. But for him, he was always a problem solver. People didn't understand material and process. And so I decided to go to school for that in the metallurgical engineering program at College of Mines at the University of Arizona. Did 2 years there, and then came home for a while, did some work in the plant, learned what I really wanted to learn in my last 2 years, went back, finished my degree, and started in the business shortly thereafter. Learned that there's a lot of mystery that's in the business, and being able to take some of my father's practical knowledge, because he wasn't a schooled engineer, he was a practical guy, and combine theory and practice to find robust solutions for our customers that allowed them to be cost effective in their businesses was a valid goal, and that's what I've been doing for the past 40 some years.
And about Phoenix Heat Treat, which are the processes that you are specialized in or the industries you serve?
Okay. At Phoenix Heat Treating, we pretty much are a full scope heat treat company, a commercial heat treater. We do neutral hardening, carburizing, normalizing, vacuum hardening of tool steels and martensitic stainless, solution treating of 300 stainless. We also do aluminum, titanium, beryllium copper, and ductile iron. The only things we really don't do right now are nitriding or induction. We've dabbled in them, but we found that we did not have a sufficient market to be profitable. And while the quality was good, we still have to maintain profitability. So we stopped those operations until the market demand it changes.
Very wide scope on the heat treat on heat treat services. Congratulations for that. And the industries are basically aerospace, oil and gas, mining. Arizona is big on mining, isn't it?
Right. We consider ourselves from the ground to orbit. In other words, we work with the mines. We work with the transportation industry. We used to have a couple of automotive customers. We work in the railroad industry on some of their their engines and the like. But aerospace is still about 45% of our business, and commercial is, which includes semiconductor industries, related industries, and obviously satellite work.
Fantastic. Thanks for sharing that with the audience, Peter. So you mentioned problem solving. Since we met a couple of years ago, I believe you were president of the Metal Trading Institute when we met. You refer to yourself not as a heat treater, but as a problem solver. Why would you say that?
Well, whenever a customer contacts us, and now at this point in time, the word is out in the Valley and even in California and Colorado and Utah, that I look for problems. I've found that most people try to stay away from problems, but that just means that sometimes that work can move. And I would rather be a problem solver, because once a customer finds out that we solve a problem, they don't necessarily want to move. They don't want to take a chance of having a lack of uniformity. They don't want to have to deal with the fact that one lot distorts differently than another of parts. So if you are the person that solves problems, people will beat a path to your door. Now it puts a lot of demand on us to be problem solvers and to figure these challenges out. But once we do so, those parts rarely, if ever, move. And that means that we can have a more secure customer base. We have customers from all over the country, from the Northeast, Northwest, Central Great Lakes area, Southeast, Texas, California, and the Mountain West. Somewhere about 8% of our work comes from outside of the state of Arizona. It was a little bit larger, but we lost a customer that was purchased by someone in China, and they moved the operation there. But those things happen. I can't get around global trade. I just have to work the best I can with the customers that we have.
And now that you have give us your approach about problem solving or heat treating, what are the major problems or challenges that those companies call you about, or they look an answer or a solution?
Well, there's two. The number one is distortion.
Distortion.
Most people are concerned that their processor or even their in-house cannot solve the problem of distortion. And the other one, and that's about 75% of them, the other 25% are the lack of uniformity from lot to lot. And that means that one lot of parts, they'll get 99% throughput, good parts to sell, and then it'll drop down to 85 or sometimes as low as 60. And that plays havoc with their profitability. It plays havoc with their ability to manage their work in process on their floor. And so what we need to do when they come to us with these problems is try to understand the scope of those problems, and then we address those problems. I do have a little parlor trick though. When someone asks me, can you help us with something? I'll say, well, can you give me a copy of the blueprint? And I'll look at the blueprint and digest it, look at the material, the process, the dimensions, and try to imagine how they're trying to make it. And then I will tell the person where his problem is before he tells me. And if I can do that, and they say, how did you know? I said, because your parts are similar to all the other parts in some way, shape, fashion, or form. And I have dealt with a similar problem on a similar part to yours, and I'm ready to help you solve yours. That usually sets the hook and allows them to then feel free to bring all of the information that they have to me, and the cooperation level just jumps to a high level. And that allows me to move the process forward faster. I mean, I literally had a customer once say, "How did you know? Were you in this customer's facility?" And I'll say, "No, but in the industry, I need to know all the capabilities of my customers or my competitors as much as possible. And I will tell them what he's got." And he's like, he was amazed that I was able to tell them how they were running their parts and why there was a problem.
Well, this was my next question. You actually advanced a little forward. Well, how do you analyze each challenging RFQ? You just told me you like to see the blueprint to take a look at the material, and you kind of compare your experience with similar parts or processes, and you actually move forward and say, "Is this your problem? Because I have this problem with these parts in the past." And most of the time they will say yes. Is that a correct statement?
That's exactly how it works. And when I'm able to predict without them telling me what their problem is, they're ready to hear a solution. They've gone past that. Maybe this person can help me. They've eliminated some of that doubt. And when we get to that next level of cooperation, you know, in a relationship of someone I've not met before, they're ready to listen more intently. Sometimes they'll jump ahead and say, "I need to get my engineers involved or my people on the floor." So we gain that level of confidence with a potential customer by showing that this is not new to us. And if you're looking to go hunting or fishing, and you find that someone is a good scout or a tracker, you immediately have confidence that your hunt or your fishing trip is going to go well. And that changes the perspective at the point of time of the problem solving and allows them to be more at ease and be ready to digest everything that comes into focus for the potential solution.
Now, this is when you have experience on a similar part. Has it happened to you that you want to develop a process, or the part is relatively new? Is there a different approach when you're going to start a new process?
Yes, absolutely. Several years ago, a customer in Texas asked me about annealing copper. In fact, there's a series of articles in Industrial Heating that detail how we went through this process. But in short, they needed to have a certain grain size and a certain hardness of this copper alloy. And to do so, they had to machine it in a hard condition, and we needed to partially anneal it. In that case, I had not had extensive experience, but I went in and studied the processing from the technical standpoint, from the theory of the process. And then I asked them for some sample material. I asked them for the reference documents as to how these parts were going to be qualified. And we use a progressive approach and by that I mean, we knew the general temperatures that we were going to be using, but we didn't know exactly where we were going to be at. So we take samples, we made a matrix of cycle times, cycle temperatures, both of them varying, and we ran those samples in furnaces. We zeroed in on a region of temperature and time. We again repeated that. We kept narrowing it down. Then we decided that, okay, we got some positive results on hardness, repeatable. We sent a sample out for the grain size analysis, and we found that we were close. We did it again. We got repeatability, and then we knew we needed to do the last step. In my world, just like baking, anyone can make one good cupcake in a big oven. It's not hard. You find the sweet spot, and then you just go ahead and make one cupcake. But there's no bakery that could survive off of making only one cupcake in a batch. So what we do is we find out what the customer's production lots are going to be like. We simulate a production load from that target set point, soak, and the like. And once we get that repeated 3 times, then we know we've got something. We sent those parts out from one of those lots because the hardness we can do in-house. We sent it out for the grain size, and it came back positively. We report that in an email for our customer to digest. And once they're comfortable, they say, go ahead and run more parts, or they send us machine parts. And literally in the situation that I just described, it was a situation where the processor and the manufacturer were no longer in business. They'd been out of parts that hadn't been manufactured in over 10 years, and they needed us to repeat what someone did that's no longer in business that they could no longer ask. And so it took us several weeks, but we were able to do something and take on a challenge that no one else wanted to. In my world, if I solve a problem for a customer, and we don't charge for this because I can't buy problems. And I know that may sound silly, but you only learn when you are solving problems.
That's true.
If you don't have problems, how do you learn? And the work that we did, working with our quality people in-house, our operators, we keep them all in the loop. We tell them what the customer has challenged us with. They feel part of being part of the solution. And now, once I have a solution, I can sell it to anybody else. And I can't sell a solution that I do not have.
And you mentioned something that I know a joke about it. What's the last process always on heat treating?
The last process is grinding.
Usually. No, it's sending the invoice.
Oh, that's right. Yes,
that's right. It's sending the invoice, right? So, but well, you mentioned an example where you develop a process, right? Sometimes in this industry, like you mentioned it at the beginning of the podcast, we're seeing, because I'm a heat treater as well, but heat treatings or metallurgy, it's compared to a black box. Correct. And some of the time it's perceived that we do it trial and error, repeat, trial and error and repeat. And that's a fair way to calibrate the result. What would you tell to the guys that are trying to develop process or get a part running by trial and error? Is that a good methodology, or should they plan a little more in advance or design it, like you mentioned, you sat down with your quality team and your engineering team, and then you had a plan and start doing trial and error. I see many companies that they just load parts on the furnaces and they just press play, right? But
Right.
the planning and the sitting down, reviewing the print, I always like to draw heating curves and carbon potentials.
Right.
That's how I like to do it. What's your opinion on that?
Well, that will work. Sometimes that becomes frustrating. And so what we do, and we do this on every part, and literally yesterday I had a similar situation. The customer was afraid to start the project. He got the bid, and now he's worried that he could, how can he make any money on these parts? The customer only asked him to make two, which told me that no one only makes two parts. They're fishing for someone who can actually make the parts repeatably, cost effectively,
Right.
on time, with the right quality. So what we do is we go backward. Most people don't think about this, but so now we're in a world that we have the standard manufacturing, which takes bar, wire, a casting, a forging, and machines, removes material, and then heat treats and on. We also now have additive manufacturing, which is a totally new thing.
Totally.
So I'm considering the old model subtractive manufacturing. Okay, you start with a more material than you need, you remove material, and then you process. Well, we have found that one of the major problems that people have, other than just the material and the dimensions, is what's hidden in the material when they buy it. We intrinsically go to thinking about what's in the material when they've purchased it that our customers don't see. We see it because we see the effects of those mill stresses, machining stresses, cold finishing stresses, and we try to understand that before we get to the trial and error. Everyone wants to think that the process, the heat treating process, I just need to tweak it a little bit. Sometimes you need to understand what's causing the part to distort. And if you can remove those stresses beforehand by performing another operation, we're able to remove the major cause of the distortion by adding a process. Now, some people say to them, well, that's just adding more money. Well, if the money that you add solves the biggest problem, which is getting rid of the distortion, and let's face it, the only way that you can test parts is to measure them. Well, measuring parts is very costly. It's a labor-intensive process. It's at the end of the process. As you mentioned, everyone wants to get that invoice out. So the head of the plant operations is saying, why are we putting so much time and effort into inspecting these parts? I thought we did a pre-production run and they were good. Well, sometimes doing a pre-production run doesn't tell you all the stories. So we take that same mentality when we look at how do we design a solution. So before we process parts, sometimes we will put those parts in an oven, and let's face it, quenching is a very violent part of material processing, and it's often the point where people think distortion occurs. So let's heat up a part to the actual temperature, whether it's an austenitizing temperature, whether it's a carburizing temperature, solution treating temperature, and then slowly cool it. Measure the part. If the part moves at that point, even with ideal racking, there is nothing that the heat treater is going to be able to do to remove that distortion, because quenching is only going to add more distortion. So at that point, we know that the stresses involved at the point when we're going to process are so great that we need to remove them. And if I look at the part and I see that it's probably not machining stresses, or I see the type of movement that we see in the part, like I had with the high temperature alloy question I got yesterday, we will tell the customer we need to do a process before to condition the material, to get it relaxed so that they can make the part. In my world, I'm not a roller coaster guy, so I'm not a big amusement park person. I do like thrill rides, but not the artificial type. But when someone goes on a roller coaster ride, the first ride is the most exciting, right? When you go the second time, some of the thrill is gone. We need to take the thrill out of the metal so that when it goes through the process the second time, it doesn't move around as much. Does that make sense?
Totally. It totally makes sense.
And someone will tell me, well, how do you know that that works? Okay, good question, right? When I'm talking to other heat treaters, how can you're just selling them more stuff, you're selling them more processing. Well, that would be true, but if it didn't work, why would they send the parts back again and again and again for what we call our real stress relief, the removing of the stresses before they can cause harm in the form of distortion that they cannot correct, or they have to spend so much time sorting apart.
I heard this many years back, and it will be a first statement to say that distortion cannot be eliminated, but only reduced. Is that a first statement on all heat treatments?
To a degree, okay. As an example, we have some parts that have keyways in shafts. The keyway is there. That keyway, if you were to look at the part from a symmetrical standpoint, that keyway on one side of the part has more surface area. And if it's a quench and temper alloy, that surface area will have a different cooling characteristic than the opposite side of the part. But if you were to fill that keyway with metal, then the thermal signature going into the quench is not of a part that has a keyway, it's a part that has no keyway. In other words, we purchase key stock of all sizes so that when customers send us material that has a keyway in it, we put material into that keyway, wire it in place, and now the part resembles something that the part is not. It resembles a part that is more symmetrical. We solve symmetry. In one particular case, it's a carburized part. We can't, they want the part carburized all over. So during the carburized process, we don't have the keyway filled. But then we stop the process after the carburizing, we put the keyway back in place, and now we have tricked the material. I have one of my sayings is, metal has a mind of its own. Okay, and I've heard that from customers. I don't understand it. It acts like it's got a mind of its own. Yes, it does. You just have to understand its mind. But my line is, metal has a mind of its own, but it's not very smart. We were able to trick the material by putting a keyway, filling the keyway so that the part didn't think it had a keyway. And so, yes, there's some truth to the fact that it is nearly impossible to be distortion free. But if you can get to a point where the distortion is, number one, predictable, number two, uniform within the lot, number three, to a point where it's cost effective for our customer to make parts and sell them on the marketplace, in the marketplace, for a profit. If the combination of us working together allows that to happen, then that part number moves from the, what I call the trouble part number stack, to the easy part number stack for the plant engineer. Once that stack of problem parts is low enough, that particular customer can tell their sales force, go get more parts. You can't continuously load up a plant with problem parts and expect to be successful.
And, I love that approach. I totally love that approach. You just made it sound so simple, and it is so true. But now my next question will be, when is good to say no or reject? I mean, because what I have heard from you is that you love challenges and you love problems. But when do you say, for me, I don't be able to solve it, or I can solve it, but it is not just, it's not gonna work. We're not gonna match it.
Well, good question. And I only have to go to yesterday's question from a customer. He asked two things. He asked, what's going to happen to this part when you heat treat it? And what's it going to cost? So I went through what I believe to be the challenge that would be faced making that part. I explained it from a practical point of view, so that a person that's not a metallurgical engineer or a metallurgist could understand it. I have to put it in terms that they can understand. And then I tell them what the solution is that we would do. And then I ask for questions. Now, I addressed the first part of it, his question. What's going to happen to the part? And the answer wasn't good. It's going to move all over the place. It was high temperature alloy, Haynes 230. The process set point was 2250. It's a disaster. And it's what I told him. I said, this is a gotcha part. In other words, somebody's going out fishing for another solution provider, another maker of the part, because they're having problems somewhere else. Otherwise, they wouldn't have asked for two pieces. But I didn't give him a quote. If he comes back to me and says, no, just go ahead and heat treat it per the print, I'm probably not going to quote it, because I know that the problem is going to manifest itself. And I have another saying: the most predictable profit I can ever get on a job, the most predictable, is zero profit. And that means that's the job that I decided to not take. Because every job that I don't get the customer buy-in to the solution that comes to our facility and explodes into a problem that consumes our quality people's time, potentially creates bad blood with a customer, sure, we give them an invoice. We've got a certain markup on it, but how do you mark up a job enough to have your quality people spend 45 minutes to an hour and a half describing why it wasn't our fault? How do we put in money for the salesman to go out and try to get the customer to understand that it wasn't our fault? By me telling them that a problem is going to occur and them not wanting to listen or try the solution, we don't get that job that blows up. Now, sometimes jobs get past me because, as crazy as it sounds, Carlos, 90% of all the work that we get, we don't quote. Now,
you don't quote 90% of the work that you get?
That's exactly right. They send it to us because they know we're going to be able to do it right.
Okay.
And of those 90% of those jobs, 80% of those orders have a $0 invoice.
Okay.
That doesn't make any sense.
No, it does not.
They're sending us work because they know we're going to be able to solve it. And they're putting the onus on us to solve the problem. Now, there'll be times when people will come back and say, after they get the invoice, "Wow, it was why was it so much?" And we tell them, we ask them first, "Are the parts good?" "Yes, the parts are good." Well, why are the parts good? Because we had to put all these steps into making them good parts. Had a customer out of Texas, same as the copper customer. They quoted us a job. We didn't get the job. And a year later, 6 months or 9 months or a year, I get an email from the quoting person asking, "Why did you quote this job so high?" I said, "Well, because there's racking involved to make these parts not want to distort on you." "Why are you asking?" "Well, we sent them to, we chose another processor." "Okay. Why, what's the problem?" "Well, they did the first article parts and everything turned out okay." I said, "Okay, well, that makes sense. Then what happened?" "Well, we sent them an order of 10,000 pieces and it took us 4 days to sort them out. And we only got, 7,000 good pieces." I said, "Well, what's your problem? You got the cheap price,
right?
But you didn't count on all that inspection time." "No, we didn't. We lost money." I said, "Would you have lost money compared to our quote?" And she said, the response in the email took a day. And I always know when people ask questions and they respond quickly and then they delay.
They pause.
They pause. It's because
Right.
they don't want to admit what the reality is. And
Right.
they said, "You're right. And to this day, we have that part, Carlos."
And Peter, you were a fourth generation heat treater. I didn't know that. It's fair to say that you were born and raised on this industry. You're very passionate about it. And do you see a lack of experience nowadays on the heat treat industry? And what are we missing on this industry? What's the biggest area of opportunity? Because you and I can be talking about problem solving, distortion, all of this, but we need more problem solvers like yourself in our industry, not only in Phoenix, Arizona, but all over the world.
Right.
But I don't see that many problem solvers on our industry because they don't have the experience.
Right.
What's your opinion on that and how our industry can address that?
Well, about 15 years ago, I had the opportunity to, friend of my wife's they had a son who's going to school for engineering at ASU in Tempe and needed a summer job. we put him through a rotation within our plant. He did a couple weeks in the alloy steel quench and temper and carburize. He spent a couple weeks in the vacuum department doing the vacuum processing, either hardening or solution treating. He spent a couple weeks doing precipitation hardening. He did a couple weeks in our salt line department doing neutral hardening, mar tempering, os tempering. And he spent a couple weeks in aluminum. He went into a job interview after he graduated. 3 different people were chosen for the second interview. He was the only one with experience. The fact that he could name alloys, processes in a practical framework, he said he got the job over people that were more qualified, better GPA, higher, better schools, because he had experience. From that point, we started working with interns on a yearly basis. We work with University of Arizona, my alma mater. We work with ASU. We work with Grand Canyon University, which now has an engineering program right in Phoenix. We've worked with a couple others back east after people heard about us, and we share the practical knowledge. If you think of heat treating, there's a balance between practical, which is what happens on the floor, and the theoretical.
Oh, it's 2 different worlds.
Right.
2 different
And
worlds.
if you do not have both sides of that brain working, it won't work cost effectively. And forget about whether I like it or not. It's what's going to be cost effective for a business. So to have an engineer who's got a master's in material science or mechanical engineering or the like, but has never had any experience on the plant floor, you have a person that only has one eye, one ear, and one arm. And so we've pushed to get interns into the facility so that they can actually see what is happening. As an example, an intern a couple years ago from the University of Arizona, he did some work. I can't talk about it because it's confidential proprietary information. Amazing stuff that we're still working on. We discovered within our processing to advance carburizing. And he went back and the second, during his junior summer, it was his sophomore summer when he was with us, he applied to the American Institute for AISI, American Iron and Steel Institute. They took his experience that he detailed and a letter of recommendation and gave him a full year scholarship. Just within this last year, another one of our interns, again from U of A, received the highest scholarship through MTI. And it was because he was able to demonstrate his desire to learn practical solutions that had a technical basis. And that's what we want. We want practical solutions that have theory that back it up so that people think it's not just a black art. It's not just voodoo. And so I think that because there's been this focus on only specially focused study, that people don't understand everything. I've never worked in a steel mill, okay, or an aluminum mill or a titanium mill, but I can describe what happens at those mills that cause us to have problems with our customers because of mill stresses. I've never machined a part, but I can tell from an alloy and how much material is removed where there's going to be problems. And it's only because I've got practical understanding and have seen it manifested on the plant floor. 1 year in a heat treating facility like ours is worth 10 years or more of experience in a company who does manufacture of all those alloys. So in my mind, and I was thinking about this, we talked about this internally in a management meeting, that realistically, the large manufacturers, the prime contractors, if they have a need for a mechanical engineer or a material process engineer, they should find a commercial heat treater and have them do an intensive 1 year program. I think we could do it in 6 months, but 1 year would be better, where they literally work for us, not just there with a notebook. They're actually working with our
hands-on,
and they get the experience in the alloys and the processes that they're going to need to address, so that they go in with that. They could be a 10-year experienced engineer if they worked in a commercial facility and saw different part numbers every day. And it's hard to get that understood, but that amount of experience cannot be purchased quickly, except for in a commercial facility that sees multiple part numbers, multiple alloys, sizes, shapes, and the like. And so we push the interns. It's not just a cakewalk. I ran into an engineer that was an intern many years ago, and I didn't even remember him. I have to tell you the truth. It was years later in an ASM meeting, and I said, "So was the internship valuable for you?" He goes, "Absolutely." I said, "How's that so?" And he goes, "Well, I decided I didn't want to be inside a plant. I was more interested in the money part. I went and got an MBA, and I got a great job, and I love what I'm doing." So some of it is knowing what you really want to do.
Right.
And if it is something that you enjoy, the challenge of this invisible art, I mean, face it, we cannot see what's happening in the furnace. We use uniformity surveys. We use process modeling to give us a view. We use thermocouples to give us an insight on what's happening. But the only way to understand it fully is to see a load go in, a load come out, and see what happens to it. And that is invaluable. They say that it costs somewhere between $15,000 and $20,000 to get a person up to speed to be profitable for a company. Well, that's not very far off of having them work for us. We don't pay them. The other company pays them. They sign an NDA so they don't steal our proprietary knowledge, but they get the experience that they cannot get by sitting at a desk.
I believe that's brilliant, if you ask me. I believe that's a brilliant approach, and we'll really encourage everybody to have an inter-program, and if you can match it up with a OEM or a prime manufacturer, like you're saying, I believe that's a home run. Peter, it's been fantastic and very, you're a very wise heat treater. I can say that. You're very technical and a very wise man. Thank you so much. It's been awesome talking to you. And all of my podcasts, all of my guests, I always like to close with this question. What would you advise to the new generation of heat treaters? We need to keep our industry growing, to keep our industry filled with people that love what they do, that are passionate about what we do, and also to retain them, right? Because we're not going to learn this in 6 months, like you said. This is a career lifetime that can aid you. what will be an advice for those guys that you, a fourth generation heat treater, that you love your job, you're passionate about solving challenges and issues? Uh, what would you say? What will you tell them?
Well, I would say that there's a very important part that most people miss. And I say that because my father actually asked me to do this, but I was too smart, right? I was a college graduate and I didn't want to do it. But now I regret not taking his advice. He asked me, you understand the process pretty well, as because I had worked in the plant summers when I was in high school, and I did a 2-year break between my engineering school and literally was a foreman on a shift. And so I saw the processes and I had learned them. But he asked me and told me, your biggest challenges will not come from just the process. Your challenges will come from not understanding how the equipment works. And the other thing that I discussed earlier, how the material comes to the customers. And so had I spent a year or more in maintenance, learning the furnaces from the inside, what their failure points were, what their limitations were. I mean, let's face it, when we love the equipment manufacturers that are always looking ahead, but they've got to compete in a market where everyone's trying to make the lowest cost piece of equipment. And that's part of the market, right? But when they leave, they make the sale and the equipment's on site, how the furnace degrades over time, because the beating that we put on metals in a cycle is repeated over and over again to the furnace, the alloy, the systems that support it, and the like. And so if an engineer wants to know the process, that's good, because he can start solving problems. But when I get caught is when the furnace starts to degrade and my process that I've designed starts to diminish in its quality. And it's so hard to have the measures on, the degradation of alloy and heating systems and refractory and recirculating fans and door seals. Those are the things that are going to be the challenge that are completely hidden until you start to look for them. And again, understanding mill operations. And while I'm there, for the people that are going into the additive field, think about subtractive manufacturing as I described it. It might have 30 steps, right? Now, in additive manufacturing, you have design, you have the powder, you have the process, you have material processing, and finishing. Now I've got 5 steps. So the focus on materials processing in the additive world is going to be of greater focus than it was ever in the subtractive world. So now we have 2 tracks. We have engineers who are going into the additive, and we have engineers in the subtractive. The engineers in the additive don't have to worry about the mill, but they do have to worry about the material and the uniformity of how it's made. But they still have to understand the equipment that's making the additive parts themselves, that process, because that's a process they're going to have to deal with, and the heat treating. So now we've got 2 sets of equipment we need to understand if we want to be an overall heat treater. You have to understand the additive process, and that equipment, and you have to understand your equipment and how it degrades over time.
Peter, thank you so much. It's been fantastic talking to you this whole hour about heat treating. I had a blast. I learned a lot. That's what I love about doing this podcast. And, just getting all this wisdom from guys like yourself. Uh, Congratulations, keep what you're doing, and next time I got a problem, I can call you. And but, but my advice to you, don't forget to send the invoice. That's the very last process of heat treating for quality system. But
I won't.
Peter, thank you so much for taking the time. We had talked a lot of time about doing this. I had a blast. Just would like to remind the audience that we're uploading monthly podcasts with power players of the heat treat industry, like Peter Hushek, president of Phoenix Heat Treat. You can follow us on Spotify, YouTube, and LinkedIn. So please hit like and subscribe to the channel. Thank you so much, Peter.
Thank you, Carlos, for the opportunity. Good luck with your podcast, and we'll look forward to the next problem that comes my way.